How can a rock weighing hundreds of pounds slide across a desert floor, carve a trail behind it, and end up somewhere completely different, without anyone pushing it? At Racetrack Playa in Death Valley, this isn't a legend. Rocks really do move across the vast, dry lakebed, leaving long grooves behind them. Some travel in nearly straight lines, others curve or change direction. And for decades, researchers could only study the evidence after the movement had already happened. Wind seemed like the obvious explanation. Except the rocks didn't behave the way you'd expect objects pushed by wind to behave. Some moved, while others, only a few feet away, remained still. And whatever made them move could disappear completely before anyone arrived. Then researchers began looking at what happens on the playa during the rare moments when the desert is flooded and temperatures suddenly fall. That changed the mystery. Because the force moving these enormous rocks wasn't acting on the rocks directly. The trails are the first clue, because they preserve something the desert itself no longer shows. At Racetrack Playa in Death Valley National Park, dark rocks sit scattered across a vast, nearly level lakebed. Most of the year, the surface is dry and hard, covered in cracked mud. Nothing about it suggests that a stone weighing hundreds of pounds could travel across the ground. Yet some of them have. A rock may sit at the end of a long groove, with a narrow trail stretching far behind it. Some trails run straight for long distances, others curve gradually, while neighboring rocks leave completely different paths. The stone is still there, but whatever moved, it has vanished. Researchers could compare the positions of rocks during different visits and see that they had changed. The trails were physical evidence of movement, not an optical illusion or a strange pattern in the mud. The difficulty was catching the event itself. A rock could remain motionless through countless visits, only to move during a rare combination of weather conditions. By the time the playa dried again, there was almost nothing left to observe except the trail. That made the tracks more than footprints. They were records of a process that happened briefly, under conditions the desert usually keeps hidden. And if wind wasn't simply pushing the rocks across the ground, something had to be changing the surface first. That last clue changes how the trails should be read. Wind can certainly push objects across an open desert, and if rain has recently fallen, wet mud can provide less resistance than the dry, hardened surface that normally locks the rocks in place. So wind and water together seem like a reasonable explanation. Except the rocks don't behave like objects simply blown across a wet floor. Some trails run beside one another as if several stones traveled together. Others bend in different directions, and a rock can remain almost exactly where it was, while another nearby leaves a long track behind. That suggests the wind isn't applying the force directly to every rock. There is another clue in the weather. Racetrack Playa can occasionally collect a shallow layer of water. If temperatures fall below freezing afterward, that water can turn into ice across the surface. The important part isn't simply that ice forms. It's what happens when the ice begins to break apart as the temperature rises. Suddenly, the dry lakebed has become a temporary system involving water, mud, ice, and wind. That provides a plausible path toward movement, but it still doesn't prove that ice is responsible. The only way to settle the question was to catch the process while it happened. And that meant waiting for the desert to produce the exact conditions that make the rocks move. For years, the missing piece was not another theory. It was an observation made at exactly the right moment. During the winter of 2013-2014, researchers placed GPS devices on several rocks and set up cameras and weather instruments around Racetrack Playa. Then they waited. Eventually, the playa flooded. Overnight, the shallow water froze into a thin sheet. By morning, the temperature was rising, and the ice was beginning to fracture into large floating panels. The researchers were watching. Then the panels began moving. and the rocks moved with them. During the December 2013 events, more than 60 rocks moved. Some traveled together, others followed different paths. The motion was slow enough to miss if you weren't looking at precisely the right place at precisely the right time. The cameras captured rocks in motion, while GPS measurements recorded their changing positions. Now the tracks could finally be connected to a physical event happening in front of the researchers. The stones were not being blown across dry ground. Floating ice was pressing against them. Wind was moving the floating ice, and the ice was transferring that force into the rocks, while the water-covered surface reduced the resistance to sliding. The first mystery had an answer, but solving it created a better question. How could a sheet of ice less than 5 millimeters thick move a rock weighing hundreds of pounds? The ice does not have to lift the rock. It only has to push it harder than the ground can hold it. When shallow water spreads across racetrack Playa, a cold night can freeze it into a thin sheet. As sunlight warms the surface, that sheet fractures into broad floating panels. Wind catches those panels and pushes them across the shallow water. Now a rock lies in their path. The moving ice presses against the stone over a broad area. Beneath it, water has reduced the resistance that normally keeps the rock in place. Once the force from the moving ice becomes greater than that resistance, the rock begins to slide. The important detail is the size of the ice panel, not simply its thickness. A panel can extend across a surprisingly large area, allowing the wind to act across a much greater surface than the rock itself. That force is transferred through the ice into the stone. And the ice doesn't have to move smoothly. It can fracture, rotate, slow down, or change direction. Those changes can alter the path of the rocks being pushed. Several stones caught by the same panel may travel together, while another rock only a short distance away remains untouched. The strange trails are therefore records of a moving ice system. They show where the ice pushed, where it changed direction, and how the rocks responded. What once looked like unexplained movement was actually a rare interaction between ice, wind, water, mud, and friction. Once the mechanism is understood, another part of the mystery becomes clear: why the rocks can sit still for so long. The necessary conditions don't happen together very often. The playa needs enough water to create a shallow layer across its surface. Temperatures must fall low enough for that water to freeze. Then the ice has to break into floating panels while the surface beneath the rocks remains wet enough to reduce friction. Finally, wind must push those panels across the playa. If one part of that sequence fails, the rocks stay where they are. And when the sequence ends, the evidence begins to disappear. The ice melts, the water drains away, the mud dries and hardens, the wind stops. The mechanism is gone. The trail remains. That is why a photograph of a rock at the end of a long groove can look almost impossible. It captures the result, but not the brief set of conditions that produced it. Racetrack Playa is unusual not because it violates ordinary physics, but because ordinary processes occasionally overlap in an extraordinary way. For a short time, a dry lakebed becomes a shallow lake. The lake becomes an ice field, the ice becomes a moving surface, and that moving surface turns the wind into a force capable of shifting stone. Then everything disappears again. So who moved the rocks? No person did. The rocks were not moving by themselves, and there was no mysterious force pulling them across the desert. They moved because a rare sequence of ordinary events lined up. Water flooded the playa, cold turned that water into ice. Sunlight fractured the ice into floating panels. Wind pushed those panels across wet mud, and the panels pushed the rocks. That explains both halves of the mystery: why the rocks move and why almost nobody ever sees them move. The movement is brief, the conditions are rare, the mechanism disappears almost as soon as it begins. Only the trail remains. And that trail is more than a strange mark in the desert. It is a record of the moment when water, ice, wind, and stone briefly worked together, turning a silent desert floor into a machine.